All right. No class next Wednesday. Next week, Wednesday, Thursday, Friday are holidays. So we'll only meet 2 days for this course, and we'll only meet one day for CSE 215. So I'll remind you of that next week. All right. Let's see. So any questions? This is our last hurrah before homework 8 gets turned in. What do you mean by should homework 8 accept input? Because I want to be careful with the terminology here. Homework 8 reads from standard in, yes. That's all it does. It does not, you don't, for example, say, main my file. Right? That's not what you want to do. The only way that you run this program is you say main, and it reads from standard in. But if you want to run it from the contents of a file, you can say main and redirect standard in. Right? But this is not something that you have to take care of inside main. You just write main to read from standard in. In bash, that's just a read statement. So when I type in my phrases, all of it works so far, but there's a value 0 that gets stored as a phrase, and I don't know how to get rid of it or why it's getting stored. You mean a phrase called 0? Or an empty phrase with a count of 0, or what exactly? So this may not be what you were asking, Thomas, but it's possible that if your input contains things like, a dot, and then some spaces, and then another dot, that the way that you're doing the input cleansing might end up making a phrase with 0 length, and that can trip things up. So when you're ready to store a phrase into the associative array, my suggestion is make sure it's not a 0 length phrase. If it has no length, then don't store it in the array. Don't set the counter, update the counter, anything like that. If you meant something else, try to re-ask it differently. How do we print our associative arrays in a loop when we don't know what the actual key value pairs are? Right? That's an awesome question. That's the tricky thing about structures like associative arrays, right? A traditional array, we know that our elements are stored at index 0, 1, 2. We just need to know how many things are stored in that array. But with an associative array, we don't necessarily know that. So what do? We use basically what's called an iterator. And in this case, our iterator looks like this. So we can say for some variable in, and then say $, curly bracket, exclamation mark, the name of your associative array, bracket, @. And that confusing gibberish of symbols will start a for loop, and each time through that loop, whatever variable you put here, key in this case, will have the value of another key from your array, and then you can use that to access, the corresponding value stored in your associative array. So that's the way that you iterate through an associative array, because as you said, you don't know what the keys are ahead of time. And we'll do a lot more with iterators in 222, 223, because we'll have lots of structures for storing information other than arrays. And in these different structures, we don't necessarily know what we're looking for, right? This may store names and addresses, or student IDs and lists of courses. And if you want to pull all that information out, unless you know what the student IDs are, how do you know what to request? So there's always going to be some way to iterate over, something like a key for these data structures. So this is how you do it for the associative arrays. Alright, once main is run, I declare a variable which redirects standard in to temp wh.text. I believe that is what I'm supposed to do when you mean the program must read from standard in. Interesting. So are you doing that redirection inside main? Because if you do that, I don't know how it would know what file it's supposed to be reading. Declare a variable which redirects standard in to temp lettering heights.text. So here's what I had in mind. Let's go over how to actually read from standard in the script. So let's just write a simpler program here, just something that's going to take an input stream and convert it to uppercase instead of counting phrases. So I'm going to say while read input line do. Okay, this is going to read from standard in one line at a time, and that line which is read will be input line. So I'll put a comment here. Input line is the next line that has been read from standard in. And I'm going to do the following. I'm going to echo input line. I'm going to pipe it into TR. Right, which is something you've already got in your program probably. I'm going to just run TR to convert lowercase to uppercase. I'm going to echo the input line, feed that to standard in of TR. I'm going to capture standard out in back quotes and set that equal to, assign that to new line. And then I'm just going to output the value of new line. Alright, so each time through this loop I'll be processing another line of input. So when I type in a line of input, it comes out uppercase. And then when I hit Control D, that signals the end of the line. Now if I wanted to feed a file to this, right, I could do reader. I can run it on itself, and there's the uppercase version of my code. Or I can feed it my .bash rc, and there's that, right? So you run the program just by saying reader, and it reads from your keyboard, right? If you run it with a redirection from a file, it will read from that file. If you you know, take a command and pipe it into your program, then standard in is coming from the output of that command, and I get my uppercase version. Right? So reading it is no more than just, you know, a read statement, read variable name. And since we want to read all the lines until the end of a file, we throw that in a while loop. So while read variable name do, and then put your processing in here to take that input line, clean it up, break it into phrases, tally the phrases. When you come out of the loop, when you get past this done, you've finished processing all the input. Now make your for loop that goes through the keys and prints out the tally for each phrase. Does that make sense? So yeah, when I test your scripts, I'll mostly be doing main less than and a file name. But I may also just run it interactively and type some stuff in. Cool, yeah, sorry for any confusion there. All right, other questions. So that's sample code, right? You won't be doing this exactly in homework 8, but that's an example of a program that reads input, a bash script that reads input and processes. All right, other questions? Keep them coming. How do I verify the key value with another value? So what do you mean by verify the key value? Are we talking about telling if you've already seen a phrase? All right, let's see, something like that. My program does not recognize key values in my associative array. So it may be that your values aren't getting stored, or that you're not retrieving them properly, or some combination. When you want to store, so let's suppose your array is called, I don't know, we'll just call it, array. I don't know if that's a reserved word or not, but we'll just run with it. So suppose your associative array is called array, and suppose you have a phrase, which is, the dog sang. And you want to store that in your array. So storing is not too cryptic. Array bracket $phrase. Right? If you set this equal to 1, that will store a value of 1 associated with this key. If I want to know what value is already stored and associated with that key, that's the more confusing looking syntax. So, something like this. So $curly name of array bracket index, and that will access an element from the associative array. So what's the usual setup, right? Remember, we're doing read, modify, write. So you've got a phrase and you want to tally it. So there's 3 steps. 1, read value from the array. So value equals $curly array bracket double quote $phrase, something like that. 2, increment the value. Right? So do this inside, $paren, and then 3, write the new value. So that's just, array bracket phrase equals that modified value. So it's 3 statements, right? 1 to read, 1 to modify, 1 to write. And you can throw echo statements in here when you're debugging, right? Before you do any of this, echo your phrase. And remember, I suggest echoing your phrase, with, before saving, phrase equals, and put some kind of delimiter. on both sides so you can see spaces that are in there, right? And then read the value from the array and throw in an echo statement, right? Initial value equals, and show what that value is. Now set your value equal to value plus 1 and put in an echo, new value equals, show the new value. And then write your value into the array, and then, maybe go ahead and do an echo. Do the same thing that you did up here when you pulled the value out, right? Echo what the new value is that's stored. And that will catch, if you're doing something wrong in here, for example, if you misspelled value, in that increment instruction, then your counts are always going to be 1, right? So you'll catch that immediately. But throw in some debug statements, right? But you really need 3 lines of code, which look like this, right? Use something like this to read the value currently stored in your array, increment it by adding 1, right? $paren, and then save that value back in by putting this on the left side and your value on the right. And instead of, using the index hello or bye or what, use the index, whatever your phrase is stored in. It's some variable. Use $sign that variable. And that should work. Let's see, when I enter an array variable, like you have written, bash tells me the command is not found. So which part of what I've written, because now I got a whole mess on my page. Enter an array variable, like what? And it says the array, oh, but you solved it just now. Okay, what was the solution? Was it spaces around the equal sign? Yeah, so you do not want that first $sign. It should just be the name of the array. So should we store our phrases in individual variables, or can we store the whole cleaned up input into one variable and work with it like that? So the way that I suggested in here, this section 3, building your index, right? So you read 1 line of input, okay, and you cleanse it according to all of this, and when you're done with these steps, that 1 line of input will now be, 1 or more phrases separated by spaces. All right, so we're doing this with 1 line of input at a time. You read the first line from standard in, and that could be a phrase, could be 5 phrases, right? Because it could have, phrase period, phrase question mark, and so on. So after you go through these steps, what you should find is that you have a variable. Let's think of it as a variable named phrases, and that's going to have, 1 or more phrases on it separated by spaces. Okay. This for statement will iterate over the phrases in that, and each time you're inside here, whatever variable you name here will be a single phrase. Alright, so inside here you have 1 phrase from that input line. You can go ahead and add that to your associative array. The next time through the loop, phrase would equal the second phrase from that input line, and so on. When you finish this, you've processed all the phrases on that first input line. Okay, now you go back up to the top and you read another line of input, and that will read the second set of phrases, and you go ahead and clean those up, extract them 1 phrase at a time, save them in your array, and you keep going like that. Wouldn't tally bracket quote $ phrase equal 1 be correct? Where tally is the name of the array. That's correct for the first time you see a phrase, but what if you've seen a phrase more than once? Right, if I keep saying, array bracket phrase equals 1, I can say that 100 times, and when I'm done, I'm going to say, how many times did I see that phrase? 1, because that's the value I stored in there. So you don't always want to store 1. What you want to do is see what the current value is that you've stored, increment it, and store that. Right? So that's the tallying part. We're keeping account of it. And so yeah, on that previous one, we've got a loop inside a loop. So, you know, read a line from standard in, clean, clean it up, for each phrase in that line, get tally, increment, save. So that's your innermost for loop that's taking care of all the phrases on one line. Here's your outermost while loop that's taking care of all the lines from standard in.
Chance, see what you reckon.
Thank you. All right, read a line from standard in, clean it up, and then for each phrase in that line, get the current tally for that phrase, increment the count, save that new count back. Okay, so this iterates over all the phrases in one line of input, and this reads successive lines of input. And when you come out of this outside while loop, now you have your tally that's built correctly, and so now you have a final output loop for each phrase in the array. Print stuff. All right, so that's your basic structure. All right, is this making more sense? Cool. All right, other questions? I actually just noticed that to exit my while read loop, I have to press Control D twice. Would that be causing the weird 0? Make sure you press Control D in the beginning of a line. Okay, don't type it at the end of a line. To signify end of file, you know, hit enter after your previous input so you're at the start of a line, and then press Control D. Alright, so there's my program that's reading from standard in. At the beginning, if I hit one Control D, that should exit. But if I type Control D at the end of a line, that doesn't signal end of file. If I hit it a second time, then it'll go ahead and exit, but it doesn't actually process that line that I was in the middle of typing. So that might be giving you that weird 0. But yeah, you can assume that Control D is being hit at the start of a line. And when you read from a file, the effect is the same. After the last line is read and processed, when you say read, again, it'll come back with false. Do our comments in the code need to be a certain length away from the actual code? Are you talking about... There's a few ways to do that, to interpret that. So I'm editing this somewhere else. That's okay. So you know, you can put your comments, you know, right before a block of code. You can also put comments on the same line. and I think there's good reason to do both. But do you need certain spacing horizontally or vertically? No. Do whatever you think makes it readable. That would be good. But you know, throw some comments in the beginning. Tell me what the script does. Convert input to uppercase, right? I might want to say more there. Might want to say, you know, this reads from standard in, converts to uppercase, and outputs to standard out until it reads end of file, right, or something like that. Put in your name, put in the date, the class, the assignment number, all that sort of stuff. While read input line, well, that's kind of a shocker to encounter, right? So how about something like this, main loop for processing standard in. Read input one line at a time. Exit after EOF. Right, and now I've got indenting in here, so you know this is at my first level of indenting. All of this stuff is at my second. That tells me that's you know, inside that loop. While read input line do. Input line is the next line that has been read from standard in. What am I doing here? Convert letters to uppercase. If you know TR, if you just wrote this, that's pretty clear that's what's going on. But if you don't say this, and somebody has never seen this code before, what do they have to do? They have to look at TR, they have to remember what this does. If they don't know the TR command, they're going to have to learn that. And then they're going to have to say, why are you echoing this and piping it, and what are these back quotes doing, right? Well, this explains exactly what's going on. Convert letters to uppercase, right? And then if you're going to, you know, change spaces to underscores, right, put comments in for that. And if you have a section of code, you know, you could say something like, you know, let's clean up the input. Let's read each phrase in the input line and add it to our tally. And then down here, you know, you can say read the current tally, increment once for this occurrence of the phrase, save the new tally back. Especially when you're writing things that look like this, that are, you know, potentially bizarre looking, just explain it in plain text. So ideally, I would like to see a lot of commenting. Now, don't just put in needless comments, right? Unless, you know, you want to throw in some poetry or something at a key spot, that's always good. But don't just, you know, add random comments because teacher said I should put comments in. But think about why you're doing things and what you can type in to explain that, so that you don't have to read bash to understand what the program's doing at each point. Okay, that's the basic guideline. What do you think about leaving debug statements in as comments? Yeah, absolutely. Anytime I remove a debug statement, my code always breaks and I end up typing it back in again. So for this class, you know, if you had echo statements in there that were being used to debug, you want to throw a comment in the front to leave them in there, that's fine. But I would say throw a little comment at the end and just, you know, say what this was doing, and I'll just happily ignore those. I know other classes, sometimes you get in trouble for having debug statements. Teachers don't want to see that. And, you know, production code, you would generally remove those debugs. But, you know, to me, we're trying to learn and get better with bash. Go ahead and leave those in. I think they're instructive. How would you throw away a slot in the associative array? Like my function thinks one of the phrases is a 0, and I just want to check for that, so when it happens, it won't print. My suggestion would be just don't store it in the first place, right? So you're adding things to the array. Before the first time you do that, just check to see if, you know, the phrase is a 0 or the count is a 0 or something, and just don't let that thing go into the array. I don't know if you can actually delete something from the array, actually delete a key from the values. But I would say if you feel like you need to do that, there's probably a better way to avoid having that in there. If you can't get away from that, though, you know, you could store a value that's recognized as illegal. For example, our counts are always positive integers. So you could store a value in there that's not a positive integer, and then any time that you're going to use something from the array, see if it's got this bogus value. If it does, just ignore it. But I think the cleaner way is don't add values to your array that you don't want in there. And I think this mostly comes up with, you know, the kind of pathological input strings like, you know, hi, comma, 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 double quote, comma, period, there. And depending on the order in which you do the cleansing and how you clean things up, it's possible that these things will end up being, you know, zero-length phrases or phrases containing just spaces. And neither of those are things that we really want to tally. And you can usually deal with those by just, you know, before you try to get something out of the array, modify and write it back. Just see if your phrase is bogus, and if it is, don't do your modify, right, or your read. All right, good. What else? All right, is that it? All right, well, let's talk more about processes in Bash. We started this yesterday, and we were looking at things like different versions of the PS command and putting things in the background and the foreground, controlling the running of processes, and so on. And we had ended by talking about signals and this idea of using a kill to terminate a process. So let's look a little further at that. So there's a bash command called trap that we can use to catch signals. Remember, a signal does not actually kill a process. It's a way to send a message to a process. So let's make a loop process. Alright, so here's a loop job that's running. It sleeps for 3 seconds and it says haha. And it just keeps doing this. If I hit Control Z, that process stops. Okay, it's not gone. I haven't interrupted it, but I've done what's called suspending it. Okay, if I say jobs, I can see I have a job called loop that stopped. It's clearly not running because it's not saying ha 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 anymore. And if I look at it, you know, it's in the middle of the sleep instruction, so here's the loop job that I just Control Z'd. And it's process ID 7317. Well, that started a process called sleep 3. But all of that is suspended right now, okay, because I did this Control Z. Now, if I do an FG, I'll bring it back to the foreground, and it continues running. And every 3 seconds, it says, ha ha. And, I can type commands here, and it's not, paying attention to standard in. There's nothing in the code that says read from standard in and do something, so it's effectively ignoring what I type. All right, if I control Z, it goes in the background again. It's suspended, and now bash is listening. So if I say print directory, it shows me my directory, and so on. Now, if I say background, and I don't need the %1, but if I say background job 1, it continues to run in the background now. But I'm still sitting here at bash. I can interact with bash, but this job is now running, on its own behind the scenes. And if I do a PS, you can see here's this program. It's sleeping, that's the state S. It's waiting for something to happen, and it created this sleep process, right, which was process ID 7350. If I do a PS again, my sleep is now 7357. It's a new sleep. So this job is running in parallel with my interactive bash session, right? So bash is listening to me. And this is also going in the background. Let's see, is that what you've done with the attendance? Oh, I have a million things running in the background, actually. That's one of them, yeah. So I have a job that sleeps 10 minutes, wakes up, takes a snapshot of the participants window, runs it through a format converter, runs it through an optical character recognition to change it into text, timestamps it, throws it into a file. But I've got a bunch of things like this sitting out here. So I have this process called timestamp, right? And anytime I hit a Control-Alt-N, I can type something in, and it forces those keystrokes into this window, throws a message up here, and then adds that to the timestamps that show up in the description of the video on YouTube. And also adds it to that running list that you can get through another web page. So I start those every time that I start teaching in the morning, but I have a script called teach. And when I run teach, it fires off all these things and gets everything going, including, starting my 2 camera viewers, positioning them, making this upper window of me sticky so that whatever desktop I'm on, it appears, and moving this, slightly up so you don't see the border of it, and all sorts of stuff like that. Yeah, so I mean this can be useful, if you're working in a Unix setup. It's nice to be able to write scripts to do things, and I have bunches of stuff that I put together mainly over the summer when it became clear we were going to stay online for a while, to help with all of this. So I have a little bash script that or a Java program that makes this countdown timer, right? That's just a window, but it gives me a visual reminder of how much time is left in class without having to decode numbers and stuff, and that pops up automatically. All right, so this is still laughing at us in the background, right? This is just doing its thing. So multiple processes. Now, I can kill this a number of ways. I can bring it in the foreground, and if I hit a Control-C, that will kill it. Okay, that's the interrupt. If I do a loop ampersand, that starts it running in the background again. So I can kill this a variety of ways. If I do a PS, my loop is 8309. So I can say kill 8309. You got to trust your typing. 8309. And that seems to have killed it. Aw. Yeah, I got laughed at, but I was also laughing. So, all right. So so this kill command sends a signal to a process, and you can read about it. Basically, you say kill and you list a process ID, and the default signal it sends is what's called a sig term, which is a terminate. but I can also specify a signal explicitly by putting a dash in front of it. All right, so let's trap signals. So I'm going to say trap, and I'm going to put in the name of a signal. What should I call it? Well, there's an option on trap. If I say trap-L, I'll get a list of signals that I can specify. So let's set up SIGINT. All right. So I'm going to trap SIGINT. And what I can do is I can specify something that I want to have happen when this signal occurs. So I'm going to say when I get a SIGINT, let's just echo the word hello. Oh, nice, nice. Yeah, payback. And you probably will be their boss one day. All right, so so trap basically says execute this command if this signal occurs. Now normally a SIGINT is going to terminate this process, but instead when I get a SIGINT I'm going to print out the message hello. So let's run my loop. All right, so it's sitting there and it's saying haha every 3 seconds. Hit a Control C and it says hello. Hit a bunch of Control C's, and every time I send that interrupt, it says haha, says hello, and it goes back to sleeping and outputting. Now I can still suspend this, and I can put it in the background, and I can say kill, and this looks like 8395. And that successfully killed it. So let's trap a sig term, and let's run that in the background. And now let's kill 8433. And it didn't kill it, right? We can kill it again, and it just says hello. Right? So when I say kill, it's sending a sig term, and that's what we're trapping right now. But if I hit a Control C, that's a SIGINT, so that's being caught. So we can catch both of those. So I can't Control C it. And I don't believe I can kill it with a kill signal like this. 8532. Right, it's still hanging out there. So there are signals that you cannot catch, and signal 9 is one of those. So signal 9 is sig kill. And so if I kill a -9, 8532, right, that will shut it down. Can't be caught, can't be trapped. But this can be useful if you have something that you don't want the person to be able to just Control C out of. Typically what you'd like to do is, for example, if you're creating temporary files that you normally delete at the end, if someone hits a Control C, you might want to go off and clear up those temporary files before you exit. You can use a trap to do that. Or create a never-ending bash script, yeah. And remember, you can still kill it Worst case, you can open another terminal session, use a kill command, and take care of it like that. But it gives you a little more control over how processes respond to things like control C's or kills. But remember, this is just signaling. So if I had two bash scripts, I could use signals to communicate between them, right? I could say something like, I'm going to use sig user1 to tell this script when there's a message for it. And so I could set up something like this. Now, we don't necessarily do this, but here's script 1, here's script 2. And I could have, some file. I'll just call it convo for conversation. And if S1 wants to send a message to S2, what it can do is write a message into this file and then send a signal like sig user1. And when this sees this signal, when it traps that signal, it can go off and it can read the contents of this and do something. And if it wants to send a message back to S1, it could put something in this file, send a signal to S1, and that would tell S1, hey, go read some instruction from this file. And this is a rudimentary way to do inter-process control, right? Have two processes that can talk to each other, even though they're basically independent entities, right? They didn't both get started from the same script or something. All right, so just some stuff about processes and their trapping and so on. Let's see how we do this in C tomorrow. We'll talk about some C system calls that we can use to do some of these things. All right, good luck with homework 8. Don't forget to submit it. Don't forget to add me as a reporter on Git. Call it HW008, and we should be good to go. All right, have a good one. See you tomorrow. Thanks.